Hello, hello. We've got another video here, continuing our study on binomials and polynomials. And this section is going to be talking about multiplying binomials again, only we're going to look at two special cases. So we have two learning targets. The first one is to find the square of a binomial, so squaring something with like an exponent of 2. And the second one is to find the product of a sum and a difference. And you'll see exactly what that means in just a little bit. All right? So, a long time ago, in a galaxy far, far away. Alright, you always use the FOIL method to you can always use the FOIL method to multiply binomials. There are, however, some special cases where you can use shortcuts. The following cases have those shortcuts. Multiplying binomials with the Star Wars theme. Alright, we're done with Star Wars theme. I just had that in my head, so we did a little bit of Star Wars intro there. But as I said, you can always, always, always use the FOIL method if you want to. FOIL method is great. This lesson is just showing you two different cases where there are shortcuts when you're multiplying binomials. You don't have to use them. If they confuse you, don't even use them. But for this section at least, this video, this lesson, I want you to at least get an idea, be able to see them if you so you can start to recognizing these shortcuts as you go along. So the first one is when you square a binomial, and what we mean by that is when you square a binomial, that would be taking a binomial like um, like this right here, a plus b squared. So if we were to write that out, it would be a plus b times a plus b. So there we have two binomials multiplied together. When you do that, if you do the FOIL method, you get a squared plus a times b plus b times a, or a times b if you want to turn around, plus b squared, which you can combine those and you get a squared plus 2ab plus b squared. Okay? So that's how you do it using the FOIL method. Took you 2 steps. Okay? That is actually showing us a shortcut already. If you want to look at it like this, here's another way to look at it. If you're looking at area, because you're multiplying things together, that's how you find area. But our key concept, the square of a binomial, here it is in words. You can write it in words. You can write it in the terms with an example afterwards if you want. But here's the words. The square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. In other words, here it is in words. So if you have a plus b squared, you end up doing squaring the first term, so that's where you get the a squared from. Doing twice the first term times the second term, so that'd be ab, and that'd be 2ab, and then plus the square of the last term, which would be b squared. The same thing goes for subtracting. You just have a subtraction sign here. So it'd be a squared minus 2ab plus b squared. Here's examples that you may want to write down that actually have numbers and variables in them. And you can see it there too. But what I'd like to do is go through this example here. Very similar to one up right above. But let's go through what is the simpler version of x plus 8 squared. So here's the procedure. It may be worth writing down the procedures when you're squaring things. Square the first term. We said to do that. So x is the first term, that's x squared. All right? Then multiply the two terms and double it. So twice the two terms. So x times 8 would be 8x. And if you double it, it would be 16x. So that's where we get the 16x there. And the last step is to square the last term. So 8 squared is 64. So here we got x squared, 16x, and 64. So our final answer for this one would be x squared plus 16x plus 64. We just follow those 3 steps, And if you know those 3 steps, it really cuts down on whether you have to do the FOIL method or not. Okay? Again, you can always do the FOIL method, but this would be the shortcut if it is one binomial squared. So why don't you try that on your own using those steps? I have 2 problems here for you. What's the simpler form of each product? We have n minus 7 squared, and we have 2x plus 9 squared. So if you'd like to pause it right now and try them through, and then unpause it and check how I work through them. All right? All right, so if you're wondering, for the very first one, I squared the first term, I got n squared. Then I did the 2 terms multiplied together, so that would be minus 7n, and I doubled it, so I got minus 14n. And then the last term would be negative 7 squared, which is positive 49. So that's where I got my new trinomial after I squared n minus 7. Same thing works for the second one. It just takes a little bit more thought because we have 2x. So if you square 2x, it'd be 2x times 2x. That's where I get the 4x squared from. All right, then I do 2x times 9, which is 18x, and I double it. So that's where I get 36x from. And then I square the 9, and I get 81. So this is the shortcut for dealing with squaring a binomial. All right. So let's take a look here. Let's read this through. Have you ever thought about something? Have you ever thought something seemed one way and found out it was totally different than what you had thought? I'm guessing that's happened to you before. Why don't you take a look at the St. Louis Arch? I have a picture right here. Does it look, at least to me it does it look like the it is taller than it is wide? I think it definitely looks taller than it is wide. But actually, guess what? The width and the height are actually the same. Even though it looks weird in the picture, they're actually the same. They're both 630 feet. 630 feet tall, 630 feet wide. So that's just a real world example of where something isn't exactly what it seems. And when we do some math problems, sometimes they look like you could easily get a certain answer, but when you actually work them out the correct way, you get something totally different. So here's an example. Kind of like one we just did. X plus 1 squared. Many times people look at that and say, well, just distribute the exponent to the two things and we get x squared plus 1 squared. But if you actually write it out, it's going to be completely different. So let's work it out. X plus 1 squared would be x plus 1 times x plus 1. Or we can do it the shortcut method that we just learned. We square the first term, so we get x squared. We multiply the first by the second term, so we get 1x, and double it, so we get plus 2x. And then we square the last term, which would be 1. Okay? Or if you just took this and you did the FOIL method, you'd get the same result. But we end up getting a trinomial, not a binomial. So that makes it totally different from the original, or from what we maybe have thought. So don't just assume, actually work it out. Actually follow the steps that we've learned here, because the answer is actually not x squared plus 1 squared. You see, it's actually a little bit quite different. All right? Now, similar to this, but slightly different, is when you multiply a sum and a difference. So we're going to multiply a sum and a difference. And here's an example in words. So the product of something plus something else, so a plus b, and that same something minus that other something else. So if we had a plus b and a minus b, it's going to be equal to the square of it's going to, the square of a minus the square of b. Oh, sorry, the square of a. I was going to say something didn't seem right there. The square of a minus the square of b. In other words, square the first term, square the second term, and put a minus sign between them. If you want it straightforward, that's a great way to put it in words. When you have, all right, in symbols, a plus b times a minus b, or a minus b times a plus b, you square the first term, it's a squared. Square the last term, b squared, slap a minus sign between them, and that's what we'll get. So if we look at this example, again, it only works if the a and the b are the same in both terms, in both binomials, and one has a plus and one has a minus sign. So we're going to square the first term. We get 4x squared. square this last term, we get 9 squared is 81, and put a minus sign between them. And that's where we get that result. So put it a different way, this is actually straight from the book. The key concept here looks just like what we did, what we just showed. So either you write down the examples from here or from here, but this pretty much explains exactly how you can do this shortcut. Or you can do the FOIL method, but it'll work out the same way this way every time. Again, FOIL method is flawless. Don't worry about if you have to use the FOIL method every time. I do it a lot of times too. But it says, what is a simpler version of x cubed plus 8 times x cubed minus 8? So here's our procedure. Step 1, square the first term. So x cubed squared would be x to the 6th power. Square the second term. So it's 8. 8 squared is 64. Put a minus sign between the two answers, and we get x to the 6th power minus 64. Keep them in the same order, though. So we kept the x's in front. So that's where we got x squared minus 64. So why don't you try it? I've got 3 examples here. Try 2 of them, and pause the video and try them on your own. And I will have them worked out for you, and you can check them in just a bit. All right, so for each of these, they have the a minus b times a plus b format. So you can square the first term, square the second term, and put a minus sign between them. So for the first one, when I square the first term, I got x squared. Square the second term, 9 times 9 is 81. And I put a minus sign between them. So I got x squared minus 81. Second example, I did the same thing. Ended up getting 36 minus m to the 4th power. And then finally, for the last term, 3c squared would be 9, or sorry, 3c, yeah, you square the whole thing, we get 9c squared. 4 times 4 is 16, with a minus sign between it, gets it 9c squared minus 16. So let's end it with this. Chris and Mike both solved the problem x minus 2 squared. Chris thinks the answer is x squared minus 4x plus 4. And Mike thinks it is x squared minus 4. Who is correct and be able to explain? This is a great one to figure out, to think about. And it ties directly to what we just had talked about. And I think it's the first part of the goal when you're multiplying, or you're doing the square of a binomial. So take a look at your notes for that and try to figure that one out. It should take you back to one of these 2 learning targets, which would be to find the square of a binomial or to find the product of a sum and a difference binomials. So those are the special cases for multiplying binomials. Feel free to use them as shortcuts, or go ahead and go back and just use the FOIL method. That'll work every time as well. So hope you learned something here, and enjoy the rest of your day. We'll see ya.